So we're going to be looking at the oscilloscope. This is a very useful tool in electronics for doing diagnostics and to see what's going on. Basically, the oscilloscope has a display, and this is a digital oscilloscope. And they used to make analog ones, but this is a digital one. And basically all this does is shows on this axis voltage, and on this axis time. So this is basically a voltage time graph and that this makes, and it can allow us to check out voltage. So to show the basics of that, I've got a multimeter here right now hooked up to a resistor, and that's all hooked up to a off to a variable power supply, and I can change the voltage here and on the power supply to whatever I'd like, and so you can see it bouncing up and down there. Now what we're going to do is we're going to hook the first channel of the oscilloscope up to the circuit here and look at the voltage. So to do that, we have a negative alligator clip, which we're going to hook up to the negative side of the resistor, and then there's a probe inside here, and that's going to be our positive. This is just a little clip to hold it in place, and we'll hook that up to the positive side of the resistor, like so. And you can see as I was hooking it up, it jumped. So this is now the voltage being measured. Now this shows about 8.8 volts. Now this is set at 5 volts, which means each of these little lines is 5 volts. So this is 5 and about 8 volts. If I bring it up to the top line, it should be about 10 volts. And so I can turn this, and now that's up at that line, and that's 10 volts. And you can see as I change it, it moves over time, it drops down. And now we're down to 4 volts, 2 volts, and a volt. Now it's kind of hard to read that because it's very close to 0 volts, which is right down the middle there. So I can use this knob here to change the scale here. So right now it's at 5 volts, now it's at 2 volts, 1 volt, and that's 1 volt per division. So from here to here, here to here, here to here. So now we can see that's about half a volt. Now I can put it on half a volt right there, 500 millivolts, so half a volt. That's pretty close. It's getting closer to that line. So now we can, we can use this to measure voltage quite easily. I can turn the voltage down even more, down to say a few millivolts. So I've got 21 millivolt, about 20 millivolts on here. This is still showing pretty close to 0, but I can drop this down to say 10 millivolts, and up it comes to that 10 millivolt. Now we can see a lot of spikes now because we're getting pretty close to the lower limit of what the power supply can put out cleanly. Now if I turn the voltage back up, you can see it going back up, and now it's well off the screen, so we just adjust until we get down. Now this is saying about half a volt, so if we come down to, there we are, half a volt, and we can bring it right back up to 9 volts. So I've got it up to around 9 volts. It's completely off the screen, so again we just adjust this until it starts showing up. So at 5 volts it shows up there. Alright, so that's showing us basically the voltage. Now you've seen it vary over time as I've changed it, but we can also look at doing this and see how adding the time dimension to this two-dimensional graph, and how that helps us see that. So we're going to disconnect the multimeter, and we're going to use this little timing circuit to show that. Okay, so I've taken away the multimeter and I've plugged this circuit in. It's just a 555 timer set to basically blink this little light on and off. As you can see, the light comes on and the light comes off. So what does that look like on here? Well, I've got a wire here that I've got connected to the ground, so we'll just connect our ground lead there. And then I have another wire here which is connected to the output of the little chip, and we'll connect our lead here. So we're now connected to the chip, and as you can see, whenever the light is on, the line jumps up, and when the light goes off, it jumps down. On, off, on, off. So basically we're now seeing over time that the electricity is turning on and then turning off, turning on and turning off over and over again. And that's basically all that's happening there. So this allows us to see that. Now, in this case, this is easy enough to see because the light's turning on and off very slowly. In fact, we can take a look and see that it's turning on and off. Now, this is set to 1 second, so each of these little divisions is 1 second, so it's turning on and off about once a second. So on for a second, off for about a little bit less than a second. Okay, again, since this isn't going very fast, that's not really much we're gonna, we need an oscilloscope for. However, let's just turn it off for a second here. And I'm going to change the capacitor that's in the circuit from this big one to this little one right here. And then when I turn it back on, the light appears to be on continuously. And up here, we're getting basically this big green bar. So what that means is that this is actually turning on and off, but faster than the human eye can see. And right now, with this set at 1 second, faster than the oscilloscope can actually show. So we can use this button here to change the time base. So we can go to half a second. So each little division is now half a second, but that's still not enough. 200 milliseconds for each of the divisions, still not enough. Now we're down to 100 milliseconds per division, still not enough. So we're at 50 milliseconds, 20, 10, 5, 2, and now at 1 millisecond, we're actually starting to see it's turning on and off just really fast. And how fast? Well, we can turn this on, keep going this till we get, so now the bars are about a little bit bigger than it is, but that's at 100 milliseconds. So from here to here is about 100 milliseconds. So it's turning off really, really fast. Our eye can't see that, but the oscilloscope can. So that's one way that the oscilloscope is really good for helping us figure out if something's working or not. Is this actually blinking on and off, or is it just on steadily? Well, our eye can't tell, but the oscilloscope can. All right? Now, the nice thing about this particular oscilloscope, and a lot of oscilloscopes, is they have more than one channel. Right now we only have one channel hooked up, channel 1, and it's showing us that light turning on and off. But there's more happening in there, and we can actually take a look and see, and that's where these oscilloscopes really are great, is they can help us see what's going on in one thing compared to another. So I'm going to bring another probe in, and I'm going to hook it up to channel 2 here. And they just snap on. And it has the same connections as the first one. So I'm going to connect the alligator clip to the minus, or the ground again. And I have another wire here. Here we are. And this is connected to another pin that's connected to this capacitor. So I'm going to connect that like that. Now we can't see anything until we turn channel 2 on with this button. And now we can see channel 2. Now channel 2 is at 5 volts, channel 1 is at 5 volts, so they're both the same scale. And now we can see that channel 2 is going up and down. And it's going up and down at the same rate, but it's doing something different. It's not straight on and straight off. Now what's happening, and then what this chip does is, at some point, the capacitor starts to charge, and it gets to a certain voltage, and the chip decides that it's time to turn it off, so it turns it off, and at that point, it turns the light off. The capacitor then discharges. When it gets to a certain point, the chip decides, okay, it's time to turn everything on again, and then it charges and discharges, charges and discharges. And that's what causes the timing. But we can see that one changing and charging is affecting the chip turning on and off. Now we can change these two scales independently. We can't change the time independently. We can change the time, so we get bigger or smaller, but we can't change that interface. Now if we have stuff on the screen, we can just hit this button here and it'll go away. So there is the two chimes. Now, if we want, we can also move these around. Right now we're on channel 2, so if I take this button here, it says vertical, I can move this down and up, and it changes where channel 2 is in relation to channel 1. 0 volts is this little, where this little 2 marker is for the channel 2. 0 volts is this one here for the channel 1. I can also move channel 1 around. I just have to hit the channel 1 button, and then I can move channel 1 up and down as well. I can also change the scale. If I want channel 2 to be larger, I can move channel 1 and make it larger. Channel 2 doesn't change. Or I can make channel 2 look larger. If I hit channel 2, I can make it look larger. Now it looks larger. And we have all that wonderful information there. I can put that back. It's usually best to have them both at the same, unless one's really much smaller. That way you can compare better. It's easier to see sometimes like that, or we can move channel 2 back up to channel 1, and it all lines up. Now, one of the other cool things about these digital guys is that we can measure things. So I'm just going to get rid of channel 2 for a moment. So I just keep pressing channel 2 till it goes away. I can get rid of that. And let's say I want to know how fast this is turning on and off. I can hit this measure button here, and it tells me all sorts of information. Right now it says the maximum voltage is 8.6 volts, and the frequency is 4.8 kilohertz. Now I can change all of these. It also says the width of the pulse and all that. I can change these to whatever I want. So if I want to know the peak-to-peak voltage, in other words, what the difference from there to there is, I can come here and I can hit this button, and I'm just going channel 1 volt, and I can then go through my menus, and there's peak-to-peak. I can hit that, and the difference between there and there is 9 volts, and that's one of the things it can measure. It can measure all sorts of different things. So that's the basics of these digital, and we can of course get display, and then that we can get rid of that information as well. So that's the basics of the oscilloscope. It does a whole bunch of other things, and there's other things that you might want to eventually learn about, but that's more for another time. This is an incredible tool, and it's a good one to learn how to use. If you have any questions, please feel free to ask.